Conditional probability with and without replacement. Suppose an urn contains 7 black balls and 5 red balls. 1, 2, 3, 4, 5, 6, 7 black. 1, 2, 3, 4, 5 red. We draw 2 balls from the urn, assuming that each ball in the urn is equally likely to be drawn randomly. What is the probability that both drawn balls are black if the selection is done with replacement? B. Without replacement. For part A, with replacement means we pick a ball, we select a ball, and then we put it back before the next selection. We are looking for the probability that both drawn balls are black. If we denote B to represent the event that the drawn ball is black, and R to represent the event that the drawn ball is red, then the question is asking us to find the probability of the first black and the second black. 2 balls drawn are both black. The selection with replacement, again, meaning that we randomly select one out of the urn and then we put it back before making another selection. Since we put the ball back, everything in the urn is the same as before. And so whatever the first selection is, it does not change the outcomes of the second selection. That is what it means with a replacement. Specifically, the probability of getting the first black ball is 7 because there are 7 black balls total out of 12. Because there are a total of 7 black ball plus 5 red ball, which is 12 balls. Once we select the black ball, we put it back. And so the probability of getting another black ball the second time is still 7 out of 12 because everything is the same. First black ball, second black ball. Each has a probability of 7 over 12. And we just say that these two events are independent. So the probability of getting the first ball that is black and the second ball that is also black is the probability of the first black ball times the probability of the second black ball, which is 7 over 12 times 7 over 12. And this is 49 over 144. And that is the probability of getting 2 black balls with replacement, independent. We could multiply the two because the two events are independent. Recall that when the two events are independent, we just simply multiply their probabilities to get the probabilities of an AND. Now, without replacement. Without replacement means that we randomly select one and we do not put it back in. And so the probability of getting the black ball the first time is 7 over 12. However, the probability of getting the black ball the second time is no longer 7 out of 12 because we do not put the black ball back. And so there are a total of 11 balls left only when we make the second selection because there were 12 selections and we took one out already, and so there are now 11. And also there are 7 black balls total, but we took one out already and we do not put it back, and so there are only 6 black balls left. This time the probability of getting the black ball the first time and the black ball the second time is 7 over 12 times 6 over 11, which is 42 over 132. Technically, the probability of the second black ball is the probability that the second ball is black given that the first ball is also black. This is a conditional probability because it is done without replacement.